Hi, I'm A. Talukdar from Surface Cleans India Private Limited. I'll be speaking on gearing up for higher load. The new axle norms. As per the new axle norms announced by MoT in July 2018, gross vehicle weight of a 2-axle truck has been increased to 18.5 ton from the existing 16.2 tons, thereby increasing the load carrying capacity by just over 20%. Similarly, the gross vehicle weight for a 3-axle truck has been increased to 28.5 ton from 25 ton. For a 5-axle truck, the vehicle weight has been increased from 37 tons to 43.5 tons, thereby increasing the load carrying capacity by more than 25%. Similarly, the load carrying capacity for other categories of multi-axle trucks has also been increased. For tractor trailers, the limit has been raised to 36%. The interpretation and implementation of the notification. The notification prescribes the maximum permissible axle load for various trucks. Increase in maximum permissible load may not increase the GVW of old trucks which have been certified for a lower tonnage by OEMs and testing agencies. The way forward would be for OEMs to develop and get certified higher tonnage vehicles on same number of axles, which may take a few months. This may involve changes to chassis, axles, steerings, tires, brakes, etc. Light and medium duty trucks are not impacted as the new norms are for vehicles with above 16.2 tons gross vehicle weight. Suppliers of these parts said that the extent of re-engineering required is minimal. A business development executive at a Pune-based manufacturer of drive shafts and axles for commercial vehicles also said their parts do not need to be drastically redesigned as they are built to carry over 40% more than the rated payload. What are the options with the manufacturers? Many of the component manufacturers claim that the existing components are over-designed by 40%, hence can easily meet the increased 20% load. This means the over-design factor will reduce from 40 to 20%. This may affect the warranty clause which has been worked out based on 40% over-design. Few OEMs have certified their vehicles at low tonnage, so they only need to recertify these vehicles to higher tonnage. This again will affect the warranty clause as explained in the previous point. Another way forward is complete redesigning to meet the new loading norms, which will involve new tooling and additional equipment. The most important factor is time and cost. In this particular slide, we are showing a graph between a typical stress versus load cycle. The y-axis representing the tensile stress in KSI on the left hand side and in MP on the right hand side. The x-axis is the number of cycles. Now let us assume that the loading was around 80 KSI, which gave 2 lakh cycles to failure. As per MoT's new notification, the loading has been increased by 20%, that is 96 KSI. Now as we can see, a linear increase of 20% in the tensile stress results in a reduction of 1 lakh load cycles, which is almost 50% of the earlier cycles to failure. Now we'll look for a solution. One important thing that we have observed in the graph stress versus load cycle is that a linear increase in the tensile stress results in reduction in the load cycle. From the previous point we get a solution. That is, if we can preload the component with a residual compressive stress equivalent to the increased revised tensile stress, then this induced residual compressive stress will counter the additional tensile stress of 20%. This will ensure that there is no impact on warranty and no design changes is required. The most practical and economical process to generate the high magnitude of residual compressive stress in such a wide varieties of part geometries is controlled shot peening. I repeat, the most practical and economical process to generate the high magnitude of residual compressive stress in such a wide variety of part geometries is controlled shot peening. In this particular slide and the subsequent slide, we are showing you the distribution of residual stress induced by different shot peening parameters. You can see from these slides that by changing the parameters, you can get different residual stress value which can be selected or should be selected as per the component requirement. The very high compressive residual stress in the surface layer induced by shot peening is extremely valuable under bending, torsional and percussive loads. The compressive residual stress induced by shot peening acts additionally to the compressive stress induced by case hardening. The primary purpose in using shot peening with gears, shafts and other parts is the enhancement of the strength and reliability of the systems and equipment that house them. Shot peening is mostly used to enhance the strength of gears, followed by miniaturizing gear speed reducers. From the above photograph you can see, by introduction of the process of shot peening, the transmission gearbox has been reduced by 20%. So an additional advantage in using shot peening is the reduction in the component size. Thank you. For any further clarifications or technical inputs, please visit our website www.surfacecleans.com. You can also send in your mail to bope@live.in.